Today I am going to familiarize you with the concept of limits in calculus. You have probably seen something written like this in college textbooks like this. Limit as x is approaching a number, let's say 2, and then the function f of x, and that is approaching a number, let's say 9. Okay, this is the notation of limits. That's how we represent limits. Now, what are limits? Limits is a really useful function in calculus that's really used to try and figure out what the value of a function f of x. So the function f of x, what is the value of this function f of x is reaching when the x value is reaching a certain number. So that's pretty much all about limits. So now let's see how these limits look like. Okay, so let's consider a number 1. Right over here, we got our x value as x equals 1, okay? And now we're going to see what is f of 1. Now, f of 1 pretty much is also 1. So this point right over here becomes 1 comma 1, okay? So now we know that when x is equal to 1, the value of the function or f of 1 is just also equal to 1. But in the limits case, we are going to see what this limit approaching, what this f value approaching when x is approaching 1. Remember, x is not 1, x is approaching 1, okay? So in the case of limits, we write it as limit as x approaches 1. X is not really 1, but it is getting closer and closer to 1 of f of x, the function, equals, there's a value what it is approaching, okay? So now we're going to see right here, as we get closer and closer to the value 1 on the x-axis, we seem to be approaching the value 1 on the y-axis. And that's pretty much the case because f of 1 is equal to 1. So as we are getting closer and closer to 1 on x-axis, I am also getting closer and closer to 1 on the y-axis. So that's how we write limits. Okay, so we've got a function f of x. We don't know what's the value of f of x, like what's the equation of f of x, but we're going to assume that after we put some values like this is the x values and these are the y f of x values, okay? I am going to consider a value called 0.9. That's a value smaller than 1, and that lies somewhere right here. That's 0.9, okay? And f of x function gives me also 0.9, or a number really close to 1 right over here, okay? And now I'm going to go a little further and input 0.99, and I'm going to get a value, again, really, really close to 1. And I'm not sure what value I'm going to get, but let's say I'm going to get 0.99 itself. And that's getting really, really closer to the value of f of x, that's 1, okay? So we write this situation right over here as limit of f of x as x approaches 1 is equal to 1. Now remember, this notation right over here is not equal to f of 1 equals 1. Okay, now let's see another case where things are a little different. Okay, so let's consider this case right over here. Now I've got a graph of y equals f of x. Okay, and now things are a little bit different here. Now, as you can see, at x equals 1, the function is undefined. There's no definite value for the function at x equals 1. But the function continues after x equals 1. So we're going to figure out what is the limit as x approaches 1 of f of x. Pause the video and see if you can figure it out. Okay, so now let's do it ourselves. Now, as we get closer and closer to 1, right over here on the x-axis, as we get closer and closer to 1, our function seems to be getting closer and closer to the value 1 right over here. So that's pretty much all we need to figure out a limit. We're going to write limit of f of x as x approaches 1 is simply equal to 1. Now, what could be f of 1? Pause the video and see if you could figure it out. Okay, so f of 1 does not really exist because the function becomes undefined at this point right over here where x is equal to 1, but the y value doesn't exist. Okay, so we're going to say that f of 1 does not exist, or it is simply undefined. Okay, so the value of the function does not exist, but the limit of the function exists. Okay, that's pretty much all to know about the basics of limits,